So for section 2.5, just a reminder, we are skipping over a couple sections. We are going to talk about how to graph tangent and cotangent, the last two trig functions. So again, we still identify the transformations for tangent and cotangent very similar to the way that we identify the transformations to sine, cosine, secant, cosecant. Reminder, you do want to make sure you have this b value factored out so that you can identify the correct horizontal shift or phase shift. So just like we saw with secant and cosecant, you are going to have vertical asymptotes in your graph because there are places, if you think about your unit circle, that tangent is undefined. For example, if you take a look at your quadrantal angles, we know that at 0, we have the ordered pair 1, 0. At pi over 2, we have 0, 1. At pi, it's negative 1, 0. And then at 3 pi over 2, it's 0, 1. Remember, when we talk about the tangent is y over x. So anytime, remember, when you have a 0 in the denominator, it's going to make the function undefined. So tangent is going to be undefined at any place where our x-coordinate is equal to 0. So if you look at our unit circle, the x-coordinate is equal to 0 at at pi over 2 and 3 pi over 2. And notice this is what the graph of one of our, what our tangent curve is going to look like. Notice you have a vertical asymptote at pi over 2. So we also are going to, this is going to be one of the most, the different one, we're not going to actually start our cycle at 0. This one is going to shift over to negative pi over 2. So to look at one cycle for tangent, we're going to be looking from negative pi over 2 to pi over 2. Another difference between the sine, cosine, and the tangent and the cotangent, the period is no longer 2 pi. The period is going to be pi. So again, remember the phase shift, make sure the b value is factored out so you can identify the correct phase shift. So unlike all the other graphs, remember to find the period. Instead of finding the period by taking 2 pi and divided by b, it's now pi divided by b, because the parent function is no longer between, the parent function period is pi, not 2 pi. So when we talk about graphing our graph of tangent of x, we're going to be looking at our parent function starting at negative pi over 2 and ending at pi over 2. So what this is going to now be, this, what the setup is going to be when we graph our parent function for tangent. The halfway point between negative pi over 2 and pi over 2 is 0. Halfway between negative pi over 2 and 0 is negative pi over 4. And then halfway between 0 and pi over 2 is pi over 4. So when you think about the tangent, we know at negative pi over 2 from the unit circle, negative pi over 2 is in the exact same location as 3 pi over 2. So this is going to be undefined. So when we graph tangent, our cycle is always going to start and end with a vertical asymptote, because tangent is also going to be undefined at pi over 2. So when you take a look at negative pi over 4 from the unit circle, negative pi over 4 is the angle down here in quadrant 4, and I know tangent is negative. And at negative pi over 4, the tangent is going to be negative 1. Tangent of 0 is 0. Tangent of pi over 4 in quadrant 1 is going to be positive 1. So again, when I label my x-axis, here's my negative pi over 2. Here's my negative pi over 4, 0, pi over 4, and pi over 2. Like I mentioned, I'm going to start and end with the vertical asymptotes. And at negative pi over 4, I have a y value of negative 1. At 0, I have a y value of 0. At pi over 4, I have 1. So this is what your tangent of x parent function is going to look like. So notice you always start and end with your vertical asymptotes. This is your lowest point, then you have your baseline, then you have your highest point. Like secant and cosecant, there is no amplitude. The reason why there's no amplitude is there's no max or min. Amplitude means max and min. So if you look at the graph, you can see we do not have the highest and lowest point. Baseline, we identify the baseline just like we do for secant and cosecant. It's going to be the x-axis unless, of course, you have that vertical shift. So the domain, when we take a look at these functions, it's going to be all real numbers such that x cannot be equal to multiples of pi over 2 plus n pi. The range is going to be, you can look at the graph, is going to be all real numbers. The period is pi, and for this parent function we have x equals pi over 2 and x equals negative pi over 2. So this is what the parent function looks like for tangent. Another thing that's different when we want to identify the beginning and ending markers when we have period changes and phase shift. The inequality that we're going to set up is going to go from negative pi over 2 less than b times the quantity of x minus c less than pi over 2. So again, just like we had for secant and cosecant, to identify the start and end when we have those period changes and phase shift, the inequality is going to be a lot different. It's no longer going to be between 0 and 2 pi. It's going to be from negative pi over 2 to pi over 2. So that is the parent function for tangent. When we take a look, we go to page 22 in the notes. If we take a look at the cotangent curve, again, your equation for cotangent, you identify the transformations exactly the same way as you did for your sine, cosine, secant, and cosecant. And just like we have for tangent and secant and cosecant, there are going to be places where cotangent is undefined. Again, think about your unit circle. We know that tangent was y over x. Remember, cotangent of x is then going to be the reciprocal x over y. So again, anytime you have a 0 in the denominator, it's going to make your function undefined. So cotangent is going to be undefined any place where y is equal to 0. So notice y is equal to 0 at 0 and pi. So you can see from the parent function that we have graphed up here, we have a vertical asymptote at x equals 0, x equals pi. So unfortunately, you're going to have a different setup for tangent as you did cotangent because they're undefined in different places. The period, just like for tangent, is going to be pi. So all of your trig functions have a period of 2 pi, except for tangent and cotangent. They're the two that have a period of pi. So when we identify the phase shift, the inequality, again, is going to be set up differently than all of the others. Notice you're going to start at 0 and you're going to end at pi because that's where the parent function has the vertical asymptotes. So if you have that horizontal shift or the phase shift and the period change, you'll want to use this particular setup. Again, to find the period, just like for tangent, it's going to be pi divided by the b value. So when you take a look at your parent function for cotangent, we're going to start at 0, we're going to end at pi. So the halfway point is going to be pi over 2. A quarter of the way through the cycle will be pi over 4. And then 3/4 of the way, the midpoint between pi over 2 and pi is going to be 3 pi over 4. So when I look at my parent function and I label my x-axis, from my unit circle, the cotangent of 0 is going to be undefined. Because again, x over y, 1 divided by 0 is undefined. Same thing, it's going to be undefined at pi. So just like tangent, you're going to start and end with those vertical asymptotes. Then, when you look at your unit circle, cotangent of pi over 4, I'm in quadrant 1, that's going to be 1. Cotangent of pi over 2 is going to be, again, x divided by y, and again, up here at pi over 2, x divided by y, 0 divided by 1 is 0. 3 pi over 4, we move into quadrant 2. That's going to give us a negative 1. So again, I've got the vertical asymptote at 0. I've got the vertical asymptote at pi. And then pi over 4 will be 1. Pi over 2 will be 0. And then 3 pi over 4 will be negative 1. And again, so the cotangent graph looks a lot like a reflected tangent. So that's what the parent function for cotangent is going to look like. The domain is going to be all real numbers, except x can't be equal to any multiple of pi. So the vertical asymptotes will be 0, pi, 2 pi, 3 pi, 4 pi, etc. And you can see from the parent function up here where you look at more than one cycle, you've got vertical asymptotes at negative pi, 0, pi, 2 pi. So any multiple of pi for the parent function is where the vertical asymptotes are going to be. You can see from the range, it's going to be all real numbers. Again, just like tangent, there is no amplitude. There's no max or min, so you can use the A value very similar to the way we did for all of the others to find that vertical stretch or vertical compression of those points. The period is pi, and your vertical asymptote for the parent function is x equals 0 and x equals pi. So those are your parent functions for tangent and for cotangent.